All right, so what we spoke about the other day was we were literally speaking about digestion and absorption, and we went through a couple different things. We went through
Speak up.
All right, so we're looking at, the first thing we did was we talked about carbohydrates, proteins, and lipids, nucleic acids, and where these things get digested. So, for example, carbohydrates, when you eat a carbohydrate, it gets digested. All these things are always going to get digested in the small intestine. That's what we spoke about. Everything gets digested in the small intestine. However, carbs get digested in the mouth, and proteins and lipids get digested in the stomach as well. So those are the things, those are the key signifiers, and we box them in, so you have to pay attention to that. Again, everything gets digested in the small intestine as far as all these guys go. However, carbs also get digested in the mouth. Proteins and lipids also get digested in the stomach. The first thing we spoke about was we spoke about amino acid digestion and absorption. That was this entire board, with the exception of this guy over here, and then carbohydrates is over here. So all this is all about proteins. How do you eat a protein? How do you drink your protein shake? How do you take your protein bar, whatever it may be? Or how do you eat something that has protein in it? And how does that protein get broken down, specifically that protein? So that's all we're talking about now, and then we went into everything else. So the first thing, right, is you have this inactive, it's called zymogen. What is a zymogen?
Zymogen is an inactive form of the protein. So you have trypsinogen, which is the inactive zymogen, as you can see, and then that would be cleaved by an important enteropeptidase, which is a proteolase, which is going to cleave trypsinogen and activate it by releasing a peptide and becoming trypsin. And that trypsin is the active protease, which is located in the small intestine, rather than the inactive zymogen, trypsinogen, which is active in the pancreas. Once trypsin has been activated and cleaved, then it activates the other pancreatic zymogens to all travel to the small intestine and to be activated by cleaving their respective molecules. So, for example, in the small intestine, the first one you can see is chymotrypsin. Chymotrypsin gets cleaved to trypsinogen to chymotrypsin, which cleaves bulky and aromatic residues.
We'll get this after.
Proteolase is cleaved to elastase. Procarboxypeptidase is cleaved to carboxypeptidase. And then you have phospholipase A2 to phospholipase A2. Procalipase to calipase for proteins, and these all come handy in order to activate their active enzymes, basically.
So basically these guys, we said everything, we literally said yesterday, everything was in the pancreas. All these inactive zymogens are in the pancreas. And then this guy's going to get cleaved. This is the very first one. That's the most important. Trypsinogen gets cleaved as he goes into the small intestine. He's going to get cleaved, becomes cleaved by enteropeptidase, becomes trypsin, and then once this guy is active, everyone else is going to leave the pancreas, come into the small intestine as well, get cleaved and become active, right? And then these guys, every single one cleaves a specific thing, right? So chymotrypsin cleaves bulky and aromatic residues. Elastase, which you said was our gastase, cleaves glycine, alanine, and serine, right? Those three amino acids. Trypsin up top cleaved arginine and lysine residues. So every single one, if you have a string of amino acids, you have a big peptide, these guys are going to specifically cleave at different parts of the strand, which is going to break down your protein.
In the small intestine.
Exactly, in the small intestine. And the last thing you have to do is now uptake that amino acid, or uptake those amino acid fragments we're in the lumen of the small intestine, right? We're in the lumen of the small intestine, and now they need to get uptaken into the cell, and then they need to go into the portal vein to go upwards, I guess, towards the liver, right?
So they need to travel into the intestinal mucosal cells. And so what you're doing is once you start cleaving, right, in the small intestine by activating all these active proteases from the act of trypsinogen traveling to the small intestine, being cleaved by enteropeptidase, activating trypsin, stimulates all the other guys to follow along. Once they follow along, they become active in the small intestine. We have released and cleaved at these specific cut sites, basically. And now those amino acids are in the lumen, and they're traveling to the intestinal mucosal cells, and they're being uptaken into the cells through primary active transport, which is what creates a gradient and allows the sodium to rush through secondary active transport, allowing the amino acids to be uptook into the intestinal mucosal cells. What that allows for then on the opposite side, on the serosal side of the intestinal mucosal cell, is the facilitated transport to allow the amino acid to travel into the portal vein, where amino acids and what we'll get to, sugars, will also be uptaken into the portal vein, which is different than when we talk about the lymph system with fats.
So that's it. That's literally exactly what happens with proteins. Then we jumped into carbohydrates. With carbohydrates, we did less of diagrams and more of just writing. But let's just run through it one by one. Carbohydrate digestion and absorption. So now you're actually taking in carbohydrates, not just protein. The first thing that happens in your mouth, salivary alpha amylase will degrade starch and glycogen to dextrins, isomaltose, and maltose. Humans cannot digest cellulose. That's just a fact. It's lost in your feces. In the stomach, there's no digestion at all for carbohydrates. We said this here. Carbs, you get digestion in the mouth and the small intestine. You skip the stomach. In the small intestines now, what's going to happen? You're going to have pancreatic alpha amylase, which could break down our carbohydrates into isomaltose and maltose. Then we have brush border cells, which are our intestinal cells here, right? Or the brush borders are really on the outside, I guess you would say. Brush border cells, it says we wrote sucrose, lactose, maltose are cleaved. Those are all our disaccharides.
And now it's sucrose breaks into what?
Sucrose, what is it? Fructose and glucose.
Yep. Lactose, galactose, and glucose, and then maltose is cleaved to glucose and glucose.
Exactly.
And then it's
I feel like that's a test question right there, bro. That it happens in the brush border cells.
Brush border cells.
The breakdown of disaccharides happen in carbohydrate metabolism.
Brush border cells.
Brush border cells.
Okay, intestinal mucosal cells, they release glucose, fructose, galactose into the portal vein.
Yep.
And so you can see here, coming from the opposite side, is that now the release of glucose, so you have the SGLT1 transporter, the fructose GLUT5 transporter.
Yes.
And then you have the second or primary active transporter that creates the gradient, allowing the sodium to rush through, as well as the glucose and galactose through the SGLT1 transporter, the sodium GLUT transporter 1,
sodium glucose
as well as
transporter.
GLUT5 we know is specific to only fructose through facilitated transport, and then GLUT2 allows fructose, glucose, and galactose by facilitated transport to leave the serosal side, again, of the intestinal mucosal cell and enter the portal vein. So now sugars and amino acids are both located in the portal vein heading to the liver.
Okay, that's that. That's amino acids, that's carbs, and then we have the last guy over here, lipids. Let's see lipids real quick.